Hi there, and welcome to this video on direct proportion. When we talk about things being in direct proportion, what we mean is as one variable increases, the other variable also increases. A very common statement you might see in direct proportion questions is like this: y is directly proportional to x. So what this statement means is your y variable, as that increases, as that gets bigger, your x variable is also going to increase, is also going to get bigger. So y is directly proportional to x is telling me that both y and x will increase at the same time. If I wanted to write this statement a bit more mathematically, I could write it like this. So this bit of notation here means exactly the same as this sentence. Y is directly proportional to x. So both statements still mean the same. This symbol here is just the proportion symbol. You might hear it referred to as the little fish or the fish symbol because it resembles slightly a fish shape. So in the video, when I refer to the fish symbol, I'm referring to this proportion symbol. So y is directly proportional to x. As you approach direct proportion questions, you're always wanting to find out by what value is x multiplied to be in proportion to y. So we're always trying to find a constant number that x is multiplied by in order to receive y. So what you'll see when I work through my examples is that your first step in solving a direct proportion question is to actually remove this fish symbol and replace it with an equals k. With an equals k. K in these questions is the constant of proportionality. It is basically, we're looking for a number which we would multiply by our x variable in order to get our y variable. And the constant of proportionality in each question will remain the same throughout the question, whereas the y and x values may change throughout the question. Okay, let's get started on a few typical exam questions so you can see how this notation looks when I'm working through a typical question. So here is a very typical question. Direct proportion questions are usually presented in three parts. You have a statement. You are then given an example where the statement holds true. And then you're asked a question which you need to calculate. So I've been told that y is directly proportional to x. So I'm dealing with direct proportion. And I'm also told that when y is 42, my x variable is 6. So I know that there's a relationship between these two numbers. And then the question asks me, can I find the value of y when you know that x is 8? So there's quite a bit of information in that question, but nearly all direct proportion questions contain these three bits of information. This is what your working out should look like, and I'm going to talk through the working out and the method. Okay, so if we look at the left-hand side of the screen to start with, the first thing I've done is I've looked at my statement and I've wrote it in maths. So y is directly proportional to x. Y, fish shape, x. So y being directly proportional to x is helpful, but what's more helpful is if we can have a bit of an equation or a formula in order to find the constant of proportionality. So the first thing I'm going to do is I'm going to remove the fish shape and I'm going to replace it with an equals k. And that is always my first step in a direct proportion question. So now I have a bit of algebra here. Y equals kx. And what I know from my second line of information is I know that when y is 42, x is going to be 6. So I'm going to use the second line of information up here to solve this equation for k. So I've substituted y in as 42, and I've substituted x in as 6. Remember, when these two letters are next to each other in algebra, it means multiply. So I'm left with 42 equals k multiplied by 6, and I'm trying to solve for k. So I'm going to divide both sides by 6 to leave me with 42 divided by 6, which is telling me that k is 7. In this question, my constant of proportionality is 7. So if I look at my second line where we came up with this equation here, this formula here, y equals kx, I've went ahead and replaced the k with a 7 because I now know that k is 7. And I've put a green box around this part of the working out because this is what I was aiming for from my working out over here. I was aiming to find a formula which will help me answer the third line of the question. So now I know in this question, y is always 7 times whatever the x value is. So the question now asks me, find the value of y when x is 8. So I take my value of x is 8, substitute it into this formula. So there's my 8 there. 7 times 8 tells me that y is 56 when x is 8. So that is my final solution for this question. Y is 56 when x is 8. But in order to get that solution, we had to follow a set method in order to work out the constant of proportionality, and then I used that constant of proportionality over here in order to help me find my solution. Let's have a look at another question. Again, it's set up very similar. You get 3 bits of information. You're given a statement, you're given an example when the statement holds true, and then you're given a question. Notice that this time the question is asking for a value of x when we're given a y value. So the last little bit of my method is going to be slightly different. Let's have a look at my working out for this question. So this is what my working out looks like. Let's have a look at the left-hand side of the screen again. Y is directly proportional to x, so I've went and wrote that in some maths notation. Y is directly proportional to x. As always, I've removed the fish symbol and replaced it with an equals k, because I'm trying to create an equation that I can solve to find k. The second line of working out tells me that when y is 120, x is 15. So I've substituted those values into my equation, and I'm going to solve for k. So I'm going to divide each side by 15. 120 divided by 15 tells me that in this question, my constant of proportionality, my k value, is 8. Now I'm left with a formula I can use to answer the last line of the question. So I know in this question, I can find my y value by multiplying my x value by 8. So when y is 76, I've substituted that into the formula, 8 times x. So this time I don't just get my solution straight away because I'm trying to find an x value. So I need to divide each side by 8. 76 divided by 8 tells me that x is 9.5 when y is 76. So that is the solution to this question. So you can see the similarities and you can see the slight differences. We always start by replacing the fish symbol with an equals k, then we solve to find the constant of proportionality. We then use that to answer the question. Because this question gave us a y value and wanted us to find an x value, the way we manipulated and solved was slightly different to the first example. Okay, let's have a look at another question. At this point, I should just mention that when we have a statement telling us that y is directly proportional, that could be wrote as y varies directly to. So if you ever see a worded question that uses varies directly, that's exactly the same as directly proportional. It wouldn't change our method or the way we approach the question. This question here is a slightly trickier question because the statement is telling us that y is directly proportional to the square of x. So y is directly proportional to x squared in this question. And this is exactly why we need this full written method to solve these questions. In the two previous examples, you may have been able to spot a pattern or identify the proportion before we had a go at using the full written method. But when we start looking at more complicated questions, including the square of x or the square root of x or x cubed, then this written method is essential. Let's have a look at how we would approach this question. Okay, again, the question is in three parts. Here is our statement. Y is directly proportional to the square of x. So I'm going to write that in maths notation. Y is directly proportional to x squared. So we're including this squared this time just to increase the complexity of this question. I'm going to do exactly the same as I've done on the previous two questions. I'm going to remove the fish symbol and replace it with an equals k because we are trying to work out the value of k in this particular question. The second line of working out tells us that when y is 48, x is 4. So I can use these two values to substitute into this equation in order to solve for k. 4 squared, of course, is 16, so I'm going to divide both sides by 16. So 48 divided by 16 tells me that my k value, my constant of proportionality in this question, is 3. So the only little bit of difference was that we had to square our x variable at this point before we went ahead and carried out the division. So now I've created a formula that I can use to answer the third line. Y equals 3x squared, because I now know that my k value from this line is 3, which is why I've included a 3 up here. And now I can go ahead and use what's in this green box to answer this question. Find the value of x when y is 243. Okay, so I can substitute y in as 243, and that equals 3 times x squared. So I divide both sides by 3 to tell me that x squared equals 81. But I'm trying to find x, not x squared, so I'm going to square root each side. So I'm going to square root 81 to tell me that the value of x in this question is 9. So even though the complexity of the question has increased by that inclusion of the square of x, the method and the way we approach it is very, very similar. We use this notation at the start. We use a bit of algebra in order to find our constant of proportionality. Once we have our constant of proportionality, we can use that to solve the question being asked, to find that in this question our x value equals 9. Okay, So now it's your turn to have a go at a few questions. I've put 4 boxes on the screen. In each box there is 2 questions. So you can see each question starts with a statement, an example when that statement holds true, and then there is 2 questions in order that you need to solve using the formula you create once you find the constant of proportionality. So there's 8 questions in total. For each question, can you show me a full written method? How did you find your K value? And then how did you use it to answer question A and B? Could you pause the video now, please, and have a go at all 8 questions? Okay, welcome back. I'm just going to go ahead and show you my full written solutions for each of these questions. So you can see on the screen now my full written solution. You can see for each question I started with writing the statement in mathematical notation, replacing the fish symbol with an equals k, solving for k to find the constant of proportionality, and then that leads me to the formula I'm going to use in order to answer questions A and B. So I use y equals 3x here to solve for y, and I also use y equals 3x here to solve for x. Very similar approaches to each question. The 4th box was a little bit more complicated as it involved x squared, but essentially you should have found that the formula you were interested in was y equals 2x squared, which you can then use to solve questions A and B. Very well done if you were able to answer all 8 questions correctly. If you have made any errors or any slight misconceptions, if you could just use my full working out to make your corrections now. Here's the first of 2 challenge questions to have a go at. If you want to pause the video at this point and have a go at this question before I talk through my solution, then please pause the video now. I'm going to show you my working out and talk through how I would answer this question. So this time, y is directly proportional to the square root of x. So again, we're just increasing the complexity of the question. There's our line that tells us when the statement holds true, and here is our question. This is what my working out would look like for this question. Y is directly proportional to the square root of x. So I've wrote the statement in algebra, in maths notation. I've replaced the fish symbol with an equals k. Then I've went ahead and substituted in 12 and 100. The square root of 100 is 10. So I've divided both sides by 10, which tells me that my constant of proportionality, my k value in this question, is 1.2. So the formula I'm using, y equals 1.2 multiplied by the square root of x. Now I can go ahead and answer the question. When y is 36, what is the value of x? So I substitute in 36 as y. I divide both sides by 1.2 to leave me with 30. 30 is the square root of x, but I don't want to know the square root of x. I want to know the x value. So I square both sides, telling me that my x value is 900 when y is 36. Very well done if you were able to work ahead of me and get your solution as 900. Again, you can see why the written method is essential when the complexity of the question starts getting that little bit more difficult. The second challenge question for you to have a go at is just showing you a typical exam question. So this is how the topic of direct proportion would be assessed in your exams. If you would like to pause the video now, have a go at answering this question. 4 marks are available, and you can see that the question has split the method into A and B. But essentially, you are following the method we've been discussing in this video. Could you have a go at this question? Could you pause the video now, please? Okay, welcome back. Let's have a look at the answer to this question. So first of all, notice that the question has been split into parts A and part B. Part A is asking you to find a formula for M in terms of P. So here is that formula here. Essentially, it is finding the constant of proportionality, which is 0.25 in this case, and then just placing that into the formula involving M and P. Exactly like we've been doing on the previous slides of the video. Then for the section B, it asks us to find the value of M when P is 5. So now it's asking us to substitute 5 into this formula, which I've done here, and then calculated the value of M. So very similar to the way we've been approaching all questions in the video, but the examiner has decided to split the question up into A and B. Very well done if you were able to get your final answer of 31.25 as the value of M. That is brilliant and shows a great understanding of direct proportion.